NFTs are the latest crypto craze. Beyond all the hype and excitement, there is potential to disrupt the way we represent ownership of goods and services. So, in this video, we'll look at what is an NFT, how NFTs work, advantages of using NFTs, and also risks associated with the current NFTs. As always, if you find this helpful, please subscribe to see more educational content, and also hit that like button to give a small dopamine boost to my brain and of course the YouTube algorithms. Now, let's dive in. NFT is short for Non-Fungible Token. Fungible means interchangeable or replaceable for an identical item. Examples of fungible goods include dollars, Bitcoin, or frequent flyer miles. For example, when you lend a $100 bill, you're generally willing to accept a different $100 bill or even two $50 bills in return. Because even though they are different, they hold the same total value. Non-fungible items, on the other hand, are not interchangeable. Each item is unique and valued differently. The world is full of non-fungible items, and in fact, fungible items are the odd ones. Examples of non-fungible items include a house, car, or sometimes even a specific dollar bill if you have some sentimental value and you don't want to exchange it for a different bill. A non-fungible token is basically a piece of data that lives on the blockchain, which acts as a digital certificate of ownership for a product or service. We can make NFTs for pretty much anything from a virtual pet to a house, or even ad space on the arm of a person. Who can enforce this deed of ownership and how will vary significantly depending on what the NFT represents. We'll come back to this aspect later on. NFTs can be made for a wide variety of assets. However, there is no unified representation for all of them in the digital world. For example, a game likely represents its in-game collectibles in an entirely different way than an event ticketing system. We can, however, extract certain basic characteristics across all NFTs and define standards. This allows developers to build general-purpose applications such as marketplaces and wallets that can be used with any NFT. There are already many standards for blockchains, but the ones commonly used for NFTs are ERC-721 and ERC-1155. This is similar to the way we have many standards on the internet to define how devices talk to each other, and on top of these standards, we build different applications such as emails, voice calls, and video streaming. All ERC standards define the functionality supported by a smart contract on the Ethereum blockchain. We talked about Ethereum and smart contracts in a previous video if you're interested, but for now, it's enough to know that anyone can write a piece of code and deploy it as a smart contract on the blockchain. At a high level, the ERC-721 standard is quite simple. Each NFT has a unique ID referred to as token ID, and any smart contract that implements this standard provides a way to check who is the current owner of the NFT and a way to transfer the NFT from one account to another. ERC-1155 extends that idea to bring semi-fungibility to NFTs. In this standard, token IDs represent not single assets but classes of assets. For example, an ID might represent swords in a game, and a wallet could own 1,000 of these swords. The two methods we saw earlier are tweaked slightly to support this. One advantage of this standard is efficiency. With ERC-721, if you want to transfer 1,000 swords, you'll need to call the transfer function for 1,000 unique tokens. With ERC-1155, we can specify the quantity and do this in a single transfer. There are many other standards for NFTs on Ethereum and other blockchains, but we won't be covering them all here. When viewing NFTs in a marketplace or a wallet, we want to see more context than a simple token ID. This is where metadata comes in. Metadata provides descriptive information for a specific token ID. Although metadata is optional, most NFT smart contracts support it by implementing the ERC-721 metadata standard. It contains a method to ask for metadata in the form of a URL. The URL points to the metadata file, which contains name, description, and an image URL for a preview of the asset. There's a good reason for using URLs instead of directly returning the data. Using a URL gives a choice to the developers on how and where to store this data, the two main options being on-chain metadata and off-chain metadata. In the on-chain option, metadata is baked directly into the smart contract representing the tokens. The main advantages of on-chain metadata are permanent storage and on-chain logic. The data lives permanently with the token. This is important if assets are intended to have long-lasting value far beyond their original creation. For example, a piece of digital art is expected to persist through ages, regardless of whether the original website that was used to create the art is still around. Any changes to the metadata will follow the logic defined in the smart contract. This gives predictability around how the asset can evolve. Despite all these advantages, most projects store their metadata off-chain simply due to the storage limitations of blockchains. You see, storing data on blockchain is very expensive. Right now, it costs over $200 to store a kilobyte of data on the Ethereum blockchain. That translates to around $3 to store the words plain crypto. When storing metadata off-chain, there are a couple of options: centralized servers or IPFS. With a centralized server approach, the metadata is stored on a central server or a cloud storage such as Google Drive. This has several disadvantages. Data is mutable. This allows us to change the metadata at will. And if the project goes offline, the metadata could disappear from its original source. This is very risky for an asset that is supposed to last far beyond the life cycle of any project or service. For these reasons, a growing number of projects are using IPFS to store the metadata. IPFS is short for Interplanetary File System. IPFS is a peer-to-peer file storage system that allows content to be hosted across different computers, such that a file is replicated in many different locations. IPFS refers to files using a hash of their content, which means data is immutable. We cannot change the metadata once it's added to IPFS. And better availability. As long as there are nodes willing to host the data, it will continue to exist. If you want to see a video about IPFS, let me know in the comments below. That's all for the technical background of how NFTs work. Now, let's dive into advantages and risks of NFTs. NFTs have many advantages compared to the traditional way of managing assets. NFTs inherit the security guarantees of the blockchain they are issued on. This makes them one of the most secure way to keep records of ownership. It's practically impossible to steal an NFT without access to the current owner's private key. NFTs can move easily across multiple ecosystems. For example, a digital sword created in one game can be accessed outside that game on different wallet apps, marketplaces, and even in an entirely different game. All this without requiring any extra effort from the developers of the original game. The interoperable nature of the NFTs also make them easier to trade outside the ecosystem they were created in. To understand how powerful this is, try selling a Fortnite skin on eBay and you will discover the difficulty of moving digital assets that you already own. NFTs represent a transition from a closed economy to an open, free market economy. We can track them all the way from creation to its current owner. NFTs by design cannot be changed after creation, and it is easy to prove scarcity on the blockchain. The programmable nature of NFTs unlocks unlimited possibilities around how an NFT could evolve. One example of this is the breeding component in the CryptoKitties. NFTs are highly liquid. For instance, you could borrow a certain sword NFT to unlock a specific level or put it as collateral in a smart contract for a loan. The possibilities are endless. There are also certain risks and misconceptions associated with NFTs. We talked about how NFTs are using IPFS or other cloud storage solutions to store the metadata. These options do not guarantee that the files will be available indefinitely. For example, say you purchased an NFT of a digital art and the image was hosted on IPFS. Sure, it's better than hosting it on a central server, but if all the IPFS nodes that were hosting this file go offline, it could make the NFT worthless. The crux of the problem is that the world doesn't have a cost-effective storage solution which guarantees indefinite availability. Buying an NFT of an original piece doesn't necessarily translate into copyrights. NFTs are merely a digital certificate of ownership. Aspects such as copyrights must be enforced through means outside the scope of NFT. Consider an NFT of a house. When you buy the NFT, the burden of giving ownership of the house cannot be enforced by the blockchain. Right now, we are relying on social contracts between the buyer and the seller to follow through appropriately. Anyone can make an NFT of anything. This is both a blessing and a curse. The low barriers for creating NFTs have allowed some people to profit by making NFTs of artwork without the consent or knowledge of the original artist. It's crucial that we verify the creator of an NFT before purchasing it. Majority of the NFTs are issued on the Ethereum blockchain. Right now, Ethereum runs on proof of work and consumes large amounts of energy, which is understandably a major concern among many creators. However, this should change once Ethereum is upgraded to 2.0, and more broadly, There are already other platforms which consume far less energy with support for NFTs. Most of the issues I raised here are not new to NFTs. They also apply to current systems we use to track ownership. NFTs are certainly unique in that they form a bridge between the blockchain world and the many things external to blockchain. Maybe one day we'll have the legal framework in place to enforce the ownership of an NFT to translate reliably outside the blockchain and into the real world. For now, it's interesting to see how this space evolves.
With that, we're almost out of time. If you have any questions or suggestions, let me know in the comment section. And also, don't forget to hit the like and subscribe button if you like to get updates for future videos. Thanks for watching. My name is Praveen and I'll see you again soon.